Let us study what are the applications of dimensions. First one, to convert a physical quantity from one system of units to another. Okay, we can change from a physical quantity from one system to another system. Second one, to check the dimensional correctness of a given physical equation. Okay, we can check whether an equation is right or wrong. Then third one, to establish relations among various physical quantities. Okay, so these are three applications of dimensions. Let us see them one by one. Let us study the first application of dimensions. Okay, that is to convert a physical quantity from one system of units to another. Okay, so for that, let's see this thing. We'll have a example here. So let's take this thing n. Okay, n means numerical value into unit. Okay, this is the first system. Okay, let's take say siege system. Okay, so n1 u1. Okay, here n means what? It is a numerical value. Okay, it is a numerical value, and u1 means what? It is a unit. Okay, so when you multiply this n1 u1 in one system, okay, that will be equal to n2 into u2. Okay, so n2 is the numerical value in the second system, say S system, then u2 is the unit there. Okay, so let's take an example here. So we'll take a physical quantity, okay, which has dimensions, okay, of A in mass, okay, then B in length, and then C in time. Okay, so these are dimensions it has. Okay, then we can see that we multiply number into the dimensions. So n1 into m1 l1 t1. Okay, m1 power a, l1 power b, t1 power c. This means mass, length and time. Okay, that will be equal to n2 into m2 power a, l2 power b, and then t2 power c. Okay, so this may be in C system and this will be in the S system. So let's see a sum based on that. Let me erase all this and then we'll see a sum here. Example sum. Let us now see the example 1.1. Convert 76 centimeter of mercury pressure into Newton per meter square using the principle of dimensions. Okay, so we are given this number here. We must change into S system. Okay, so this is in centimeter, means in C system it is there. We must change into S system. Okay, let's see how to do that. So let's see the formula of pressure. Okay, so pressure is P is equal to H rho G. So this is a formula of pressure. Here P means pressure. Okay, H means the depth. Okay, or you can say height also. Then rho means density. Then G means acceleration due to gravity. Okay, acceleration due to gravity. So it's all given here. Now what we must do now? We must find the pressure in terms of S system. Okay, let's see how to do that now. We'll substitute this in the formula. So what is given here? It is given here. The siege system is given. Okay, so in siege system we are given a pressure. Okay, pressure, that is P is equal to H rho G. H is how much? 76 centimeters. Okay, into rho, that we must remember, that is density of mercury is 13.6 into, and then G in the S system, sorry, in the siege system it is 980. Okay, then we get here 9 centimeter square, 9 per centimeter square. Okay, so dyne is the S or siege unit of force cell. Okay, so this one we know. Now let us see how to change into this one. Okay, dimensions. So we'll use that rule here. So and then we'll see pressure P1, that is in the siege system. Okay, so let's left side we have this siege system and right side we have this SA system. Okay, so in siege system we have this pressure P1 into M1 L1 T1. Okay, power M1 power A, L1 power B, T1 power C. That's equal to, in the S system that will be pressure P2 into M2 power A, L2 power B, and then T2 power C. Okay, so we must get the pressure P2 in S system only. So bring this term downwards here. So to bring it downwards, what happens we'll see now. Okay, let me write this side. So we have here P1 into M1 L1 T1 power A, this power B, this power C, that's equal to pressure P2. Okay, and then division we saw now. This division we must bring down. That will be M2 power A, L2 power B, and then T2 power C. Okay, so we can rearrange and write also now. So pressure P2 is equal to P1 into, okay, this M1 by M2 is there, and common we have A power A. So M1 by M2 power A into L1 by L2 power B and into T1 by T2 power C. Okay, so then we got this now. We must see what is this M1, M2. Okay, let's study that now. So we'll take this CG system and then we'll take the S system. So in CG system, okay, and this is the S system. So in CG system, M1, L1, T1. That is what is the unit of mass, length and time. And here in a system, what's the unit of mass, length and time also. Okay, so for S system I uses M2. Okay, and for CGs I use M1 terms here. So CG system, mass is measured in grams there. Okay, length is measured in centimeters, so 1 centimeter. Time is measured in seconds. And in a system, mass is measured in kilogram. Okay, length is measured in meters, so 1 meter. Time is measured in seconds. Okay, and then you must also see the dimension of pressure. Okay, I'll write that side now. I'll erase these parts here and write that side. So I've erased these parts here. Let me go side. Let us now see what will be the formulas now. We'll substitute and see now. Before that, let's see dimension of pressure. Okay, so dimension of pressure. Okay, this you can remember or you can derive it, force by area. Okay, so dimension of pressure is M L power minus 1, okay, and then T power minus 2. Okay. How this comes? Okay, so dimension pressure is equal to force by area. Force is what? Mass and acceleration, that is M L T power minus 2, mass and acceleration. Area is L square. When this L square goes up, it will become L power minus 2 now. So M L T power minus 2 into L power minus 2. So we get here M L power minus 1 T power minus 2. Okay, that's how this comes here. Okay, let me erase this part here now. Okay, now let us substitute this values and see. Okay, so from this we compare it. Okay, so M power A, L power B, T power C. So we get here A is equal to M power 1 now. Nothing is there than 1. So A is equal to 1. B is equal to minus 1. C is equal to minus 2. Okay, we get this terms here. Next, what you must do? Substitute in C. Okay, so let's see this equation is 1. Okay, substitute in equation 1. Substitute in equation 1. Okay, so substitute in C. So pressure P2 is equal to pressure P1. That is, we already written this now. That is 76 into 13.6 into then 980. Okay, into this one. That is M1 by L1. M1 is what? 1 gram. Okay, but you must change into kilogram. Okay, so 1 gram is 10 power minus 3 kilogram. Okay, then M2 is what? It is 1 kilogram. Okay, power. Okay, power A is, that is 1. Okay, you can see that power A. Then L1. Okay, L1 is how much now? L1 is 1 centimeter. 1 centimeter means 10 power minus 2 meters. So 10 power minus 2 meters divided by meters divided by, and L2 is 1 meter. Okay, then let me erase this part here. Time T1 by T2. Okay, so time T1 is what? It is 1 second. Okay, T2 is also is 1 second. Okay, and then this is A. Okay, B is what? B is minus 1. Write to minus 1. C is how much? It is minus 2. Okay, let me erase this parts here. Okay, so let us continue here now. Okay, let us write this down. So 76 into 13.6 into 980 into this, see this now, 10 power 3 by 10, 1. Okay, that is 10 power minus 3 only. Sorry, that is 10 power minus 3. Okay, power 1, that means nothing to change. Okay, we leave it as it is. So 10 power minus 3 into second one, and then you can see meter and kilogram cancels. Here meter and meter will cancel, second will cancel. This is 10 power minus 2, power minus 1. So multiplies inside. So minus into minus will become plus. So 10 power 2, and then here this will become 1 now. 1 power minus 2 is how much? 1 power anything is 1 only. So this is 10 power minus 3 minus 2 is 10 power minus 1 will get. So 76 into 13.6 into 980 into 10 power minus 1. Okay, so when you do this calculation, we get here pressure P2 in the system will be 1.01 into 10 power 5 Newton per meter square. Okay, so this is the pressure in the SI system. Okay, this pressure P2 in the system. So this is the answer that we get here. Okay. Thank you for watching.